All right, guys, so we're going to be taking notes on Objective 1.3b, which is solving linear equations containing fractions. Our instructional objective today, I'll be able to solve equations with fractions using common denominators. I will be able to solve equations with fractions using common denominators. Bless you. There are 3 vocabulary terms in the vocabulary section. However, 2 of those vocabulary terms go with tomorrow's notes. So you can just cross out restrictions for today and extraneous solutions. For today, those are our tomorrow notes. When we start putting x's in the denominator, then we have to look for those things, extraneous solutions and restrictions. Okay, so today focus is fractions when we don't have a variable in the denominator. Okay, so least common denominator is our vocabulary. I'm not going to define that. I just want you to know when I write LCD, I'm looking for the least common denominator or the lowest common denominator, your choice. You guys ready? Can I go? Just want to know if I've given you enough time to write all that down. Yes. Okay, so we're going to go to the note section then. And the first thing we're going to do is we're going to write this information. Actually, I would like you to go back to yesterday's notes. If you could just flip back to those for just a moment. Just for a moment. And I am going to... Okay, in yesterday's notes, in the steps for yesterday's notes, we had step 1 and step 2, if you recall. Step 1 is clear the fraction, and step 2 is distributive property. I don't want to change that, but I do want you to note that these 2 steps are interchangeable. Okay, and sometimes it really is better to do step 2 before step 3 if both fractions and the parentheses exist in the same problem. Okay, so if you could just make that, just say they're interchangeable. I can switch them if I want. Okay, and then we're going to go back to your other page of notes. Okay, so my advice, if you're not real familiar with solving equations that are just loaded up with fractions, is this. If fractions and parentheses coexist, comma, it's better to distribute before clearing the fraction while you're mastering this type of an equation. Okay? Okay, so let's talk about what it means to rewrite an equation. And I talked to you a little about it when we were going over yesterday's homework. But let's just make it sure it gets into your notes. So let's say that I have, let's do this. We're going to call these equivalent. I can spell that word. Equivalent equations. I can spell. What is the matter with me today? Equations. Equivalent equations. It's really a powerful thing to realize that you can take an equation that you don't want to look at and you don't want to work with and change it to an equivalent equation that's in a much nicer format, or it's made up of nicer numbers. So for example, I could say, I'm just going to compare these three. X plus 1, let's just do a really basic one, equals 2. Okay? Let's write an equivalent equation. Now here's what we know. X equals what? 1, right? Do you agree? X equals 1? Okay, so let's write an equivalent equation so that our variable has a coefficient of 3. So how would I have to change the 1 and the 2 so that I could have a lead coefficient of 3? Multiply everything by 3. That would be a 6, right? They are equivalent equations. They both have a solution of 1. Now, how would I rewrite this equation if I wanted to have my coefficient be divided by 2? What would I have to do? Everything over 2? So 1 over 2, and 2 over 2 is 1. They're all equivalent equations because we said x equals 1, right? So if I put a 1 here, that's 1/2 plus 1/2 equals 1 whole, true statement. So of all of those, you probably would prefer to solve the first equation, right? Because you can do that in your head. You can immediately see the answer, right? So when we see equations like this, what we want to do is get rid of that fraction by using the least common denominator. So let's do that. To do that, I'm going to pick up a different color pen, and I'm going to use the least common denominator, which is what? What's my LCD here? So I would multiply everything in the equation, and I like to do it singly, everything, so I don't miss anything. I multiply each thing by 2. And so we get 2x over 2, which is x, and 2 times 1/2, which is 1, and 2 times 1, which is 2. It's the same equation, but I like it better, right? So I think if you can grasp that concept, and I'm 100% sure you can because you're brilliant, that's all we're doing today. Okay? All right, so that we basically rewriting the equation into a format or a set of numbers that we'd much rather work with. So let's start off with number 1. Ready? I'm going to erase all this real quick. Okay, so number 1, and I'm going back to my pencil. Number 1. We have, what's it, 2/3 p minus 3 equals p over. Okay, so here we have the equation, and it's not a friendly equation, right? So we're going to rewrite it as an equivalent equation and get rid of the fraction. We don't have to distribute. We don't have any parentheses here. So what we do, the best thing to do is use the least common denominator so that you don't have big numbers, big fractions in the end that you have to reduce or simplify if your answer happens to be a fraction. All right, so let's identify the least common denominator of 3 and 12. It's 12. I have to make them the same denominator. So the first denominator they can both be is 12. I can rewrite this times 4 times 4, right? I could, but I don't want to do that. So I'm going to multiply everything in this equation by my least common denominator. So I'm going to use the same color that I used to write down the least common denominator. So I realize that I'm going to rewrite this equation without fractions by multiplying everything by 12. And then I'm going to pick up another color. So now I'm going to multiply my numerators. So 2 times 12 is 24 thirds P, right? Because I'm multiplying 12 times 2 divided by 3, minus 12 times 3, which is 36. And then I'm going to multiply 12 times P over 12. And after this first problem, I'm going to skip this. I'm going to show you what to do. But I want one of your problems to have every single step. Okay, so you know what's going on. All right, so now let's divide or simplify and get rid of these fractions. That should be a 12p over 12. Sorry. That should be a 12p over 12. I know what I was doing. I'm writing the wrong thing down. Okay, so I'm going back to my original. I'm going to simplify this to 8p because 24 divided by 3 is 8. Minus 36 equals p. And now that's a new equation. It is equivalent to my original, but it's a lot easier to deal with. So I think personally I would bring the p here and take the 36 there. So that's what I'm going to do. You do how you want. And then divide the 7 off to get 36/7. And then what I'm going to tell you is this. Because that problem started with fractions, I want the answer to remain a fraction. And I don't want it in mixed number. Leave it in proper. Just make sure that you can't simplify it. And you can't simplify 36/7. Please don't ever change an answer from a fraction to a decimal unless the original problem contained decimals. That's just something to remember for me, okay? Whether it has fractions or whole numbers, fraction answers, that's what I want. Unless the problem starts with decimals. What's going on upstairs? Elephants. Right? Is there an English teacher above me? I swear they do like acting. Ah, but he's in that side. Okay, number 2. So here's what I want you to do. I want you to do number 2 without me. I'll work number 2 on the board. You work number 2 on your paper. Let's see how you do. stop me from doing this. Keep going. You got it. Keep going. Did you see what I did? You did see what I did. Like that constant time real quick? But I wanted you to have like a whole thing. You can divide first and then multiply. No, because they don't have a common factor. Oh, I skipped steps. What do you need? Right. And at least common denominator is 30, so that's my red. Oh, I cross-simplified. I divided instead of multiplied. Here I multiplied first and then I divided. Here I divided 2 into 30 is 15. And then I multiplied so that I didn't have to write that out before I got to here. Cross-simplified is what I did. Does that make sense? Awesome. Yes?
Why would at least common denominator be 30?
Because you can't make, you have to go with the largest denominator that's 5. And then you have to see if you can make the other two denominators 5, and you can't. So the next one would be 10. Can't make them both 10. Next one's 15. 20. 25. 30. So it doesn't even have to be least common denominator. Good question. You can just do 2 times 3 times 5. 6 times 5 is 30. It's a common denominator, and it will get you the answer.
But can you do them all?
Always. But I wouldn't want to use 36 on this one because then I'm reducing this at the end. And that's why I like to use least common denominator. But you can always just use any common denominator. It's a good question. Okay. So we're going to go do number 3 now. If you don't have any more questions about number 2, and some of you I sent on to do number 3, let's take a look at number 3 so that you can see my simplification process that I did on number 2. Let me get rid of that, and let me just open another page. Okay, so here we go. So your last problem, number 3, is 3x minus 5, 6 plus 2x over 3 equals 4x plus 2 all over 3. So I'm looking at this going, well, I don't like that. I don't like that format. So I'm going to use the least common denominator of 6 because I can make them all 6. So I'm going to multiply. And the reason that I do each term by 6, some teachers will just multiply the left side of the equation by 6 and the right side of the equation by 6 and distribute. I like to do this because my next thing that I would prefer to do is to cross simplify. So I can't cross simplify that, so I'm going to get 18. But 6 goes into 6 once, so I'm going to distribute a 1. 3 goes into 6 2 times. Oh, and hang on a second. I got to put the 6 over here. Okay. And then 3 goes into 6 2 times. So now I'm going to distribute 18x minus 1 times 5 is 5 plus 2 times 2x is 4x equals, and I'm going to distribute 8x plus 4, and it's a much friendlier form of that equation. So that's why I like the colors, so you can see each step separately, and it avoids that second or third step that we did in problem 1. We don't have to rewrite it. Okay, combining like terms, that's 22x minus 5 equals 8x plus 4, and I'm going to start skipping people. That's 14x equals 9.
So dumb.
Don't say that. You just go, boom, my mind opened. That's awesome. Oh, it's not on your growth mindset list? You can add to my growth mindset list. No. In your own mind. We could put sticky notes up there. You're right. Okay, so I got 9/14. Okay. So what thing specifically was it that you didn't notice?
The cross.
Oh, the cross canceling, right? It's nice, right?
Yeah, that's so easy.
It's just efficient.
Yeah.
And I'm all about efficiency. Okay, so if you take a look real quick at today's assignment, you'll find that it's a little bit busier and filled with more fractions than your note page. So we're going to do number 24 from that assignment on the back of that note page. So you can see, you can write at the bottom of your note page, see back for more complex problem or something. We're going to do problem 24 together. And P.S., your assignment is to do the odds, and the extra credit is the evens, and everybody's going to get at least one extra credit because we're going to do an even right now. I would suggest that you guys have a calculator handy when you're doing your homework tonight, just so that you can do some quick calculations and you're not stuck doing longhand multiplication or division. Okay, so this one is the beast. When I looked at this worksheet, I thought, yeah, that one's the beast. Number 6 isn't quite as bad, but it's pretty ugly too. All right, so 24 is negative 149 over 16 minus 11/3 r equals negative 7/4 r minus 5/4 times the quantity of negative 4/3 r plus 1. Oh my gosh. This thing makes you want to cry. I know. I'm glad this isn't my homework. Just kidding. Okay. I always do the homework because I want to anticipate your questions and think about them. So yeah, I do. Okay. So first things first, in this problem, fractions and parentheses coexist. So we're going to distribute first. We're going to distribute first. So I'm going straight to here to distribute. Okay? Question?
So if fractions and parentheses coexist in the problem, would you always distribute them?
Yes. That way you're not clearing the fraction, because you can only clear fractions that are outside of the parentheses. If you're going to do that, you don't want to do that. You always want to distribute first. Okay, so first I want to point out that when I'm distributing negative 5/4 to negative 4/3, here's something I'm noticing right here. Do you see those? I can simplify those to ones. In my head, I'm not going to cancel this 4 out because I do have to distribute the 5/4 also to the 1. But do you see it? Negative 5 over times negative 4 is 20 over negative over 12, but I don't want to reduce 20 12ths. So I'm going to cross simplify in my mind the 4s. So it would be positive because it's negative times negative, 5/3. And then negative 5/4 times 1 is negative 5/4. Thanks, Austin. Wow, that's a little bit crooked, my problem there. I'm going to straighten it out a little bit.
Can I do that?
Don't you wish you could have one of these to do your homework on? Be pretty sweet. What? Oh, thank you. That's what I was missing, right? Good eye. Okay, so we've distributed. Now it's time for our least common denominator. Again, I'm looking to my largest denominator and thinking, can I make 3 and 4 both 16? No. So I'm going to count by 16s. The next one would be 32. I don't think I can make a 3 a 32. How about 48? Well, 3 times 4 is 12, and 12 goes into 48, so it'll work. So I'm going to go with 48. Oh, I know. I told you it was a mean one. That's why we're doing it together. Okay, so we're going to multiply everything singly by 48 so we can cross cancel as we go. Yeah, that's why we're doing it together. This is why you can see now why I told you to have a calculator handy when you're doing your homework tonight. No, most of the math you can do, most of it you can do in your head. But I don't really know all the multiples of 149. Okay, so now I'm going to start. So I'm switching colors again so I can start doing my simplification, my cross simplification. 16 goes into 48 3 times, which means 3 goes into 48 16 times. And 4 goes into 48 12 times. And 3 goes into 48 16 times. And 4 goes into 48 12 times. Okay, I already know this math. I've done this problem 3 times already. So we're going to distribute. So we're going to multiply. So that's negative 447 minus 176R equals negative 84R plus 80R minus 60. No, because there's no R on that last one. Then I'm going to combine those guys. So if you don't mind, I'm just going to rewrite it as negative 4R instead of rewriting the entire problem. You guys okay with that? So I'm just going to go like that because I'm combining like terms and saving my hand. Okay, so I think I'll move the R's to the right and my constants to the left, so I'm going to add 4R and cancel it from that side. And I'm going to use additive inverse, add 447 to that side. Cancel that out. And that gives us negative 172R equals 387. And then all we have to do is divide, of course, by negative 172. So that's going to be a negative 387 divided by 172. And guess what? We can simplify that. By dividing the numerator and the denominator by the very common factor of 43. If you knew your factors of 43, it'd be helpful. The final answer, we'll just divide by 43, divide by 43. 43 goes into both of them. How many 43s are in 387?
A lot.
9. And this is negative divided by positive, so we're going to say negative 9 over 4. Solution. I have the answer key. That's how I got that. Yes. You always have to simplify fractions if you can. We did the hardest one together. I'm pretty sure that one was the most annoying of all the problems on that worksheet. Question?
We're done with these notes for today, so tomorrow we need questions and summary, right?
Yes. So that's the end of the notes for today.